this video, we will be looking at how to solve for missing sides or missing angles when you have multiple triangles, and this time we're actually going to deal with oblique triangles as well. So in our first example, our goal is to solve for the height of the triangle. So this type of question can be paired up with a question asking about the actual area of this triangle, which means you need the height. So our goal is to find the height, which means ultimately we will be working inside of a right triangle. So whether it's the right one with the 70 degrees or the left one with the 32 degrees. And the choice is really yours. I am gonna just pick this left one. And if my goal is to solve for this height, that means I need to know either the adjacent side or the hypotenuse, just some other side, so I can use SOHCAHTOA to solve for h. Now this 18 centimeters that is on the bottom, it is the length of the entire BC. So we don't actually know the base of the right triangle, we know the base of the entire oblique triangle, which means we first have to look at the entire triangle. So we have to look at triangle ABC, and we're gonna have to solve for one of the sides. And because I've chosen to look at the left-right triangle, my goal is to solve for this little c, so side C. And while I'm at it, I am gonna label all the other sides. So side B and side A. And if we look at this triangle as a whole, I have two angles in this oblique triangle, which means I can solve for angle A by doing 180, subtract 32, subtract 70, and I get 78 degrees. So now I can see that I do have this full pair between side A and angle A, and I have angle C, which means I can solve for side C. So that's going to be my first step. I'm going to use sine law. So side A is 18 over sine of the angle equals side C over sine of the angle, which is 70 degrees. And now I'm just going to cross multiply. So C times sine 78 is equal to 18 times sine 70. And then I can divide both sides by sine 78 to cancel it out on the left. And now you can go to your calculator and type this in. Now be very careful when you type it in. You can do the numerator, press enter, and then divide by sine 78. Or if you do it all at once, make sure you do have brackets around your numerator. So try it out on your calculator. If you have to pause the video, do so just to make sure you are typing it in correctly. And you should get approximately 9.8 centimeters for side C. So now that we have the hypotenuse of this right triangle, I'm going to focus on that triangle that I originally highlighted in red. And now I can see that 32 is my reference. The height that I'm looking for is opposite. The adjacent is the blank side because I don't actually have it. The 18 is for the oblique triangle, it's not for the right triangle. And then the hypotenuse is that 9.8, which means I'm looking for opposite and I'm given hypotenuse, so I am gonna use sine in this scenario. So I have sine of my angle, which is 32, is equal to the opposite, which is h, over the hypotenuse, which is 9.8. I'm going to put sine 32 over 1 and do a quick cross multiplying, so that h equals 9.8 times sine 32. And if you plug that into your calculator, you should get approximately 5.2 centimeters. And that was the goal of the question, so we found the height. Now we can always extend this and actually find the area of this triangle ABC. And because I have the height and the base was given to me as that 18 centimeters, I can do the base times the height divided by 2 to actually get the area. Let's go on to the next one. So here we are trying to solve for side X. Now this side can be seen as part of a big right triangle over here, or part of a small right triangle. Either way, we are given an angle, but we're not given a side. This 15 meters is for this oblique triangle on the side. So your first goal is to pick one of your right triangles, and you're gonna have to create a goal to solve for probably the hypotenuse of the triangle. So my goal is going to be this little right triangle with the 30 degrees. I'm going to try to find x using that right triangle. I can't find the adjacent side. It's not shared with my oblique triangle, but the hypotenuse is. So the first thing I want to do is solve for the hypotenuse, which I've labeled as y, which means I'm going to focus on this oblique triangle here. So I can tell that I'm probably going to be using sine law because I have the 20 degrees and I'm looking for its opposite side. And I do have the 15 meters, but I don't have that opposite angle. But I can use my angle properties to find those missing angles in this triangle. So this angle here is supplementary to the 30 degrees. Because it forms a straight line, we know that if I just do 180 subtract 30 to get 150 degrees, those two angles have to add up to 180. And now they do. And now I have two angles in my triangle, so I can use my 180 rule. So 180 subtract 150 subtract 20, and that is 10 degrees. Now, if I look at this, I have a full pair between the 10 and the 15 meters, and then I'm looking for y, and luckily I have its angle. So now, once again, we are going to use our sine law. So 15 meters divided by sine of the angle it's paired up with, which is 10 because it's directly across from it, is equal to the side I'm looking for, y, over sine of its angle, which is 20 degrees. And now we can cross multiply to solve for y. So why don't you go ahead and pause the video here and then come back once you've solved for y to check your work. All right, so hopefully you got 29.5 after you cross multiplied and divided out that sine 10. So I am just going to label that in my. And now looking at this right triangle, 30 degrees is my reference, x is opposite, the blank side is adjacent, and what I just solved for was the hypotenuse, which once again means I want opposite, I have hypotenuse. So thinking about SOHCAHTOA, because we are inside the right triangle, we can use sine once again. So I want you to go ahead and pause the video here and finish this question up, set up your sine ratio, and solve for x. Then come back to check your work. All right, so we should have had sine 30 equals x over 29.5 because we want opposite over hypotenuse. When you cross multiply, you are multiplying 29.5 with sine 30, and you should get 14.8 meters as your final answer for x. So in both of these scenarios, we had to solve for a missing side that was shared by the two triangles we had, the oblique one and the right triangle. So we had a combination of sine law and our basic SOHCAHTOA. Now let's go to our last example. So our goal is to solve for angle x. I just want you to pause the video here and think about what you would solve for first so that you can solve for x at the end. And you might have multiple calculations that you have to do, but think about it, have a little goal in mind, and then come back to see if you're on the right track. Okay, so we must start with the right oblique triangle. So this one right here, because we definitely don't have enough information in the left triangle to solve for x right away. And your first instinct might be to solve for that third missing side because it is shared. So I'm just going to label that as y. And because we have that two sides in an angle configuration, we are going to use cosine law. So let's go ahead and do that first. So y squared is equal to the other two sides squared, subtract 2 times 30 times 22 cos 40. And now, if you plug that into your calculator, you will get approximately 372.8213351. If we press the square root button, we will get approximately 19.3 centimeters for y. So I am going to go ahead and label that in my diagram. Now if we look at our left oblique triangle, we still don't have enough information to solve for x because all we have is two sides. And you might say, well, I want to do sine law here because I'm looking for x and I have its side length, but I don't have any angles in this triangle to create a full pair, which means we need to find an angle. Now, if I can find this angle in my triangle on the right side, then I can use supplementary angles to get this angle, and then I can do my nice sine law to get angle x. So we actually have to do another calculation before we ultimately go and solve for x. So I'm going to label this angle z. So I'm looking for angle z and I have its side length, which is 30 centimeters. And then using the 19.3 that I just came up with, I have its angle 40 degrees. So I have a full pair there. So step 2 will be a sine law. So I have the 19.3 divided by sine 40 is equal to the 30 centimeters divided by sine z. And now we're going to cross multiply here. And because we are solving for an angle, we are going to have to isolate for sine z and then take the sine inverse to get our angle. If you just remember that you have to do that inverse function anytime you're solving for an angle, you'll avoid some silly mistakes. So now I'm going to divide both sides by 19.3. And whatever I get there, that's what I'm going to take the sine inverse of. So you can do it all at once in your calculator if you'd like, or do 30 times sine 40 divided by 19.3 first and then take the sine inverse. But make sure you don't lose any decimals, and again, be careful with your brackets. So I recommend that you try this in your calculator. So what I would do is 30 sine 40, and I press enter. Then I divide that by 19.3, and now I take sine inverse of my answer. And if you have an answer button on your calculator, you can save all of those decimals. So if you have to pause the video to try it out, go ahead. Otherwise, we should get 88 degrees for Z. And now if we have that angle, we can use our knowledge of supplementary angles and do 180 subtract 88, and you get 92 degrees for this angle. And now we have a nice full pair between the 24 centimeters and the 92 degrees. And then I'm looking for angle X, and I have its corresponding side, which is 19.3. So we're gonna do another sine law. So why don't you pause the video here, set up your sine law, and solve for angle X, and then come back to check your work. All right, so we should have 24 over sine 92 for our full pair equals 19.3 over sine X. Then you can cross multiply and divide out the 24. So ultimately you're taking the sine inverse of 19.3 sine 92 over 24. And hopefully you got 53 degrees for that angle. So this scenario did take a few extra steps, but whenever you have these multiple triangle setups and you're looking for a side or angle, try to find a side that they share. Try to solve any angles that you can find. And if you're not sure where to start, just solve for something where you see that full pair, or you see a cosine law setup and that you have that duck formation or all three sides no angles. try to do something. And once you find one missing side or a missing angle, hopefully it will open up more doors for you to solve for other things that will ultimately help you find your goal side or angle.